Hello and welcome back to question 2. Now in question 2, we have to show that p plus q is a factor of p cubed minus 3p squared q plus 4q cubed. Now I know that some students have a problem understanding what do you mean is a factor of. Let me show you with a concrete example. Now if I want to show that 3 is a factor of 12, how do I do it? I can just say that, oh, you know what, 12 is equals to 3 times 4, right? So a factor means that, I can break it down into a multiplication of simpler substances, right? Kind of like digestion, or, that's what it is. You break something up into a multiplication of simpler terms. That is factorization. So to show that p plus q is a factor of this, there are two ways to do this actually, right? One is a really, really fast way, right? Which I'm not going to do. I'm going to do the longer method, which involves long division. Why are we doing a longer method? And that is because if you look at part 2, I have to eventually factorize the whole thing completely. Factorize completely means that, you can't write it as 3 times 4. You need to write it as the simplest possible terms possible. You need to factor everything out, even split 4 into 2 and 2. Something like that, okay? So I'm going to do long division, keeping part 2 in mind, yeah? So with that, let's get started. So if I want to show that, this thing is divisible by this, then let's do long division, right? Get this out of the way. Let's do long division. A good revision of long division with polynomials. Okay, and this is divided by p plus q. Now, the first thing you need to worry about in long division is I'm going to try and whittle down this expression term by term, right? Starting with this one first. Just like when I do long division, I'll say 570 divided by 3. I don't really worry about 570 as a whole. I just worry about the first digit 5 first, then maybe the next digit, so on and so forth, right? The same principle applies over here. So how do I get a p cube? Multiplying, what do I need to multiply with p plus q to give me a p cube? And the answer is a p square, right? So I'll get a p cube plus p square cube. Don't worry too much about the p square q. We'll, resolve that eventually. But for now, I'm very happy that p cube is gone. And this will be negative 4p square q. And bringing down the next term, plus 4q cube. Now, how do I resolve this term? I need to multiply by a negative 4pq. That'll give me a negative 4p square q, negative 4p q square. And if I subtract, this will be a 0. Right, and I'm not going to write it down since it's a 0. But what's interesting is that I have a minus negative 4p square, so there's a positive 4p square, and plus a 4q cube. Right, this is a 4q cube minus nothing, so I have this. Now I need to resolve this. How do I get rid of this? I need to have a 4q square here. That results in terms cancelling out very nicely here with no remainder. And that is how I can prove that p plus q is a factor. So you can say that by long division, I've shown that p cube minus 3 p square q plus q, is it 4q? Oh, yeah, sorry, 4q cube is equals to p plus q multiplied by this quadratic expression here, p square minus 4pq plus 4q square. Okay, and that is the answer to part 1. Now, this is especially helpful in part 2. So let me copy this. Because in part 2, I had to factorize it completely. To factorize it completely, I can see that, hey, I have a quadratic here. Maybe I need to factor this. And this is very nicely in the form of a square minus 2ab plus b square, where my a is p and my b is 2q. And this is 2ab. Think about it. 2 times p times 2q, negative 2ab, sorry, yeah? So that means this will be p plus q, p minus 2q all squared. Now I factorize it completely, right? So it was worth it to do long division because then it makes our part 2 much, much simpler. Now let's move on to part 3. Part 3 says to solve this equation. Now this equation kind of looks like something cubed minus 3 times of that same thing square times something else minus 4 something else cube. So you can probably see that this is p, q, q. So that gives me p cubed minus 3p squared q plus 4q cubed, which is something that I've done before in part 2. So if I let m plus 2 equals to p and m minus 3 equals to q, then solving this equation is the same as solving p cubed minus 3p squared q plus 4q cubed equals to 0. Then you can say that from part 2, I've already factorized this into p plus q, p minus 2q cubed equals to 0, and that tells me either p plus q equals to 0 or p minus 2q equals to 0. So it tells me this: p equals to negative q or p equals to 2q. And now I'm going to substitute back my m plus 2 and m minus 3. So that tells me m plus 2 equals to negative m plus 3, or m plus 2 equals to 2m minus 6. This will give me m equals to 8. This will give me m equals to half, which is the answer for, let me just do a quick check. Yeah, that is the answer for question 2. Hope that helped, and I'll see you in question 3.